Hello, grade 9. Here is lesson number 6, simple chemical reactions. We're going over the simpler, 3 most simple types of reactions today, and then the more complicated ones are our next lesson, which will be on Friday. So here's your time for today. You're going to need to have space at the beginning to just show the different parts of chemical reaction here, and then, and then description. And then the types of reactions here, bigger image and description, law of concentration of matter, and then balancing. There's going to be a bunch of practice problems. Some of them we'll do, and you'll get the correct answers after you have a chance to practice yourself. You can do this on scrap paper, or you can do your notebook and kind of leave space for that. And there will also be practice questions, which are going to be homework to do. You'll need to write those in your notebook somewhere, maybe on another page, so you have space, so you can upload that for feedback from your teacher. Okay, so first things first, what is a chemical reaction? This is the drawing I want you to draw, and I want you to use color. Or the best you can use the colors shown here, because red is a symbol, the color we always use for oxygen, black always for carbon, and white always for hydrogen. So you can use the actual colors that are here, that would be best. This is the drawing to draw. Okay, so you've already seen hundreds of thousands, if not millions, of chemical reactions in your life, lots of them, and you've seen them happening mostly outside the lab. You've seen them happening in your kitchen, seen them happening in the world outside you, seen them happening just everywhere all the time. They're constantly happening in the world. And what a chemical reaction is, the formal definition, is the change of one or more substance, which are called the reactants, into one or more different substances, which are products. So my reactants here in this reaction here is methane gas and oxygen, and my products are carbon dioxide and water. So to do this kind of thing, what we have to do is all those chemical bonds they're learning about, you have to break them, break the bonds in the reactants, and then make new bonds in the products. So these hydrogens, the bonds of the hydrogen and the carbon, those bonds are broken apart. And then bonds between the carbon and two oxygens are formed to make this molecule here to make carbon dioxide. And those hydrogens then form bonds with oxygens to make waters. So we're breaking bonds and making new bonds. Many times, a great example that you've seen a ton of times is combustion, when you're burning anything. And we'll talk about combustion reactions more next lesson because that's a more complicated type of reaction. But that's what this reaction here is showing. It's combustion of methane. So we have methane gas, which often people use in their gas stoves, or can be used in gas stoves. And then we're going to burn it in the presence of oxygen, and that produces carbon dioxide and water. Okay, so there's types of chemical reactions. There's 3 we're going to talk about, and I want you to draw this one, okay? So when we're predicting and analyzing chemical reactions, one of the best tools to help us be able to do this successfully is to classify them. If we can figure out what different types of reactions are and identify the patterns in the way the different bonds are being formed and broken, it makes it a lot easier to figure out what's going on. And as we go on and take science next year, and if you choose to take chemistry in grade 11 and grade 12, you'll end up doing some more and more predicting reactions. So the better you get a handle on these patterns now, the easier it'll be in the future. So the first type is called the synthesis reaction, as this was modeling here. It's where we have 2 or more reactants that are going to combine to make a single product. So we have the square and the circle combining to make a single product. You can also, this is also the same thing here. This is also the synthesis. We have hydrogens and oxygens. The bonds are breaking between them to form new bonds to make water. Decomposition is basically the opposite of this. It's where we're going to take a single reactant and we're going to break it down into 2 or more simpler products. So let's take that water and break it back down into hydrogen and oxygen gas. That would be a decomposition reaction. Very logical names. And the third type we're going about today is called a displacement, a single displacement reaction. And that's where one element is going to displace another element in an ion or in a compound. So here I have a compound plus an element, and then that element's going to kick out the blue circle, and now we have a different compound and a different element. those are the 3 for today. So here's some more examples of them. And it's a good idea to add these letters, A, B, onto the drawings you just made. If you add it onto these drawings, it should help you clarify this. People tend to use either the symbols or these letters. I find if I use both, it's really helpful for me to understand and remember the different patterns I'm looking at here. So if I have A plus B makes AB, that is synthesis, right? So I have potassium plus chlorine makes, and can you name this? Potassium chloride. I have carbon plus oxygen makes carbon dioxide. Okay, and then I have here is my decomposition. I'm going to have AB decomposing into A plus B. So I have mercury oxide down to mercury and oxygen. Other examples, I have water down to hydrogen and oxygen gas. I have sodium chloride to sodium and chlorine. Okay, this one here, what kind of reaction is this? Is there a single displacement? Can you figure out the A's and B's and add letter C for this one? So I have magnesium plus copper sulfate, producing copper and magnesium sulfate. And that pattern is A plus BC gives B plus AC, where B is my copper, C is my sulfate, polyatomic ion, magnesium is A. So you don't have to copy this down, but definitely copy the letter patterns down for each type. And it's always good to have reaction examples, but you'll be looking at lots of those today. So if you want to add this to your notes, go for it, but you don't have to. You should have the letters though, okay? Okay, so here we're going to test ourselves. Here are 7 reactions. Take a minute to identify what the types are. What type of reaction is each one? Use your notes. Again, you don't have to copy these down, but you can if you want to. What are they? Pause the video, identify them. Okay, well the first one here is single displacement. I have a single element on both sides, big hint, and I have a compound here where I'm just switching one element in each compound. Decomposition, I have a single compound breaking down to 2, decomposition. I have 2 parts becoming 1, that's synthesis. And here again I have single displacement. I have silver nitrate plus copper gives copper nitrate plus silver. I'm just switching out the copper and the silver. Here again, this is a displacement reaction. I have pentane, that's not pentane. Propane plus iron. I'm going to break it down here. This is a synthesis reaction, making 1 compound. Here I have 2 switching around, displacement, and here I have 1 really big compound, the polyatomic ion, breaking it into 3 parts as decomposition. Okay, so let's talk about the law of conservation of matter. So this is a really important law for chemistry, kind of fundamental idea. It's actually our big idea number 2. So chemical reactions we just did, this whole table I just gave you, those are actually incorrect. Some of them are anyway. And the reason why they're incorrect is because they are not balanced. So we need to balance chemical equations because of the law of conservation of matter. And the law of conservation of matter tells us that matter cannot be created or destroyed. So if we look at this reaction here, I have 2 oxygens giving 2 waters, 1 carbon dioxide, 1 methane. And those coefficients in front, the 2's in front, that's the equation for balancing the equation. The matter here, if I have, like example here, I have sulfur plus iron. I have 32 grams of sulfur plus 56 grams of iron. It gives me iron sulfide, 88 grams. So I'm not losing anything. The matter is all conserved. So we're going to look at this in a virtual lab. So here, let's go to the virtual lab. Here it is, and you just go to this link. It might say it's unsafe, but it's a safe, secure website, so you can trust it. It's from an administration of technology. So you just follow the instructions and click the different beakers, different grad cylinders to kind of make your reaction happen. I'm not going to do the whole thing for you. You can do that. And then what you're going to do is then you're going to fill out this table in your notes. So you're going to fill out for the reactants, the chemicals, what are the names of the chemicals here, the reactants, or the names of chemicals or products. They give you the full name, they don't give you the formula, so you can write the full names out. Description, what do the reactants look like, each of them? What does the product look like? And what's the initial mass of reactants, the initial mass of products? And then answer these 5 questions. So pause the video. The lab is linked in the Schoology post. Go ahead and do the lab. To help you guys visualize, here's a video of this reaction happening not in a simulation but in real life. So here I have a clear liquid, my barium chloride, sodium sulfate, and they're adding the clear barium chloride and it's immediately white. Now this could be a solution or a precipitate, so if I let it sit, the precipitate will kind of fall down. This is what you witnessed in the reaction in the lab. So the answer is here. You have sodium sulfate and barium chloride, and your products are barium sulfate and sodium chloride. You had 2 clear liquids to start with a mass of 150.2137 grams. And here is that solution here for the initial mass. Then after you mix them, you had a white precipitate in clear liquid. Here it is. The white precipitate is the powder here in the clear with the same mass. Here's my reaction. Barium chloride plus sodium sulfate. I'm going to flip my ions. So your answer to the question should be things like you need to make sure you have goggles on, correct glassware, and you're using I don't need gloves as well. If it's corrosive, you need to have gloves on as well and a lab apron. Why don't you just mix it in a beaker with a test tube? Well, you want to make sure that nothing leaves the system. It's a closed system, so you make sure that no gases leave. You'll lose any matter that way. What did we learn from the simulation? Well, hopefully you learned that the mass of the reactants is equal to the mass of the products. What's the chemical or physical change, and how do you know? So it's definitely a chemical change. A chemical reaction is always a chemical change, and because I have a precipitate, that's my sign of chemical change. And how does it demonstrate the law of conservation of matter? Well, the mass of the initial is the same as the mass of the final. Okay, so let's talk about actually applying this to balancing equations. So to make sure our equations accurately represent the law of conservation of matter, we have to balance them. And what that means is to make sure there are equal amounts of each element on each side of the chemical equation. So here I have 4 hydrogens, I have 1, 2, 3, 4 hydrogens. I have 2 oxygens, I have 1, 2 oxygens. It's balanced. Nothing disappears, nothing is added. So what we do is we add coefficients, these big numbers in front, we add them to balance the equation to make sure the total number of each molecule is the same on each side. So here I had iron oxide plus carbon gives iron plus carbon dioxide. And I had to add a 2 in front of here and a 3 in front of here to make this work. So we can walk through this step by step. The first imbalance I'm going to notice here is that I have 2 oxygens here and 3 oxygens here, which means I have to have 6 oxygens on each side to make it work. So if I put a 3 here, that gives me 6 oxygens, and a 2 here, that gives me 6 oxygens. Great. But now I have 4 irons. And here I only have 1 iron. So I put a 4 in front of the 1 iron, and now I have 4 irons and 4 irons. But now I have 3 carbons on this side, so I had to put a 3 in front of this carbon, and then double check, everything is balanced. This will get a lot easier with practice. So I'm going to show you guys a really cool website, and I'll link it in the lesson that you can use to help you practice this. And this is from the University of Colorado. We've used them before. So there's 3 parts of this. You can do with sandwiches, molecules, or a game. So to do the sandwiches is that you have the reactants. You can put 2 slices of bread and 1 piece of cheese. That makes 1 cheese sandwich. If I have extra cheese, but no more bread, I have leftovers. And we don't want any leftovers in my reaction, right? So I want to make sure I have enough bread to go with the cheese to make full sandwiches. I can be more complicated, add meat and cheese. Crazy. It's a crazy sandwich world. I can add more meat, add more cheese, but I need to have enough bread to make this work, but I want extra bread either. It's all about balancing. Okay? If we look at molecules, this is a more accurate one. Here's the chemical reaction at the top, and it's balanced. You're going to add some hydrogen, add some oxygen. I need to add more oxygen, add another hydrogen. Oh, look, I have 2 waters, but I have an extra Oxygen, if I take an oxygen away, there we go. It's balanced, no leftovers. I can make ammonia, same thing, and I can combust methane, same thing, just mess with them and change them until you get it all to be balanced out. My favorite one for practice is the game here. You can pick a level, and what you do is you have to make this work. This is the product. So I need to add enough reactants to make this mix of products. So here's my chemical reaction. I need 1 methane and 4 sulfurs to make a single carbon sulfide and 2 hydrogen sulfates. So I have 2 of those and I have 1 of these. But if I look here, I have other things too. I have 1, 2, 3, 4, 5 methanes. 1, 2, 3, 4, 5. Add extra methanes. I have 1 extra sulfur. And that's it. I click check. Hey, I got it right. And then you can get another question and try it again. It's a really way to practice. Okay? Okay, so we'll go back to our balancing equations here. So that's how that theory of that works. It's the same number of atoms on both sides of the reaction. We don't lose any matter, we don't gain any matter. It's equal on both sides. So here's those same reactions we had before. I want you to pause the video and balance them. Add coefficients to balance these equations. Pause the video to do this. Okay, so here are the correct answers. 2 of these reactions were already balanced. The first 2 are already balanced. I double checked it. Nothing to change there, so that's good. But the rest of them had to change something. So I had to add a 3 here, because I had 3 oxygens, and that gives me 6. So I had to add a 2 here to make that work. And I get 4 phosphates and 4 phosphates. That one works. I have to add a 2 to the silver nitrate, a 2 here for the silver because I have 2 nitrates. Remember the brackets for polyatomic ion means there's 2 of everything inside the brackets. 2 here, that's all I had to do. This one's longer. I had to add 4 different things, and I had to add 1 thing. So again, it just takes practice. So practice, practice, practice doing these. If you need help, feel free to ask your teacher to help you. Okay, that brings me to our second big idea. How can we observe the concentration of matter in the world around us? So how can we make sure matter is not destroyed or created in reactions in the world around us? And then your homework is to do these practice questions. So here's 7 more reactions that are new. You need to both balance them and identify the type of them. Okay, do both of those and make sure it's clearly written in your notebook with the numbers. So you'll be getting feedback on that from your teacher. Okay, so your homework is to upload a copy of your notes, which should include your notes and big idea number 2. The virtual lab table should be in there as well the balanced and identify reactions in the last pink table practice questions. The other practice ones you don't have to do in your notebook. You can. It's always good to have extra notes with good information in it. You can also on a scrap paper or a little whiteboard, anything like that you have. Okay, so this is a longer lesson and there's a lot of material, and we're going to keep building on this next lesson. So hopefully you can get it, and we'll just practice, practice, practice. Take care.